Dear viewers, welcome back. In this session, we are going to talk about logical data independence versus physical data independence. First, we talk about what is data independence. In file system, there is no data independence. The file system, the data is well protected and there is huge dependency on its own data. Each and every data is tightly coupled with one another. If you want to share your data to someone else, you need to write a separate application program for achieving the task. If you want to make your data interoperable between the environments or to any platforms, in that case, file system would not allow you to do the task. If it allows, then you need to write a separate application program specifically for the particular task. That has become an advantage in database management system. Database management system has a full independence on this data that's stored in the database. If you want to share your data to anyone else, yes, you can do it. To any viewers, any external users, yes, you can do that. There is a full control for the users to access the data if it has been permitted. Based on the grant privileges it has been given to the database, yes, the data can be shared to anyone else. There is a full logical data independence on that part. That is what we are going to discuss in this lecture. That is what the data independence is all about. It doesn't mean that data is loosely coupled in DBMS. Since we have been talking about the data has been shared very easily to any environment or any platform, it doesn't mean that the data is loosely coupled. In fact, it is tightly coupled. But what is the privileges and the facilities being enabled on DBMS is somewhat amazing and impeccable. That is what we are going to discuss elaborately in this session. There are two types of independence. One is logical data independence and other one is physical data independence. Before you know what is logical data independence and physical data independence, I request you to see the video that has been posted already in our channel called the level of abstraction. I would recommend you to see the video first and come back over here so that you would have a good understanding and overview of what data independence is all about. There are three levels of abstraction. One is external level, or it's called as view level. The second level is called as a logical level or the conceptual level. And the third level is called as physical or internal level. The external level is always talks about users, application programs, interfaces, external applications. Those things comes under the external level. Normally it is all about users and applications. And center middle level layer is called what conceptual level or logical level. There it all about structure, the schema of the database. What is the attributes? All the definitions and declarations of the schema is been defined very perfectly in the middle level. That is called a logical level or conceptual level. And the internal level, or it's called a physical level, which is the lowest level of the organization, which talks about how the data is being stored internally, in what format it gets stored, how the file organization has been changing, what is the data structure has been enabled for it, what sort of changes we can make on the internal level, who can do that. So those all things comes under the physical level or internal level. So what is the difference between logical data independence and physical data independence? First I talk about what is logical data independence. That is, any changes that we do in the logical level should not affect the user or any of his application programs associated on the database. Whenever I do any changes, it should not affect the external level. It shields the user from knowing what is there in the conceptual level. That is a kind of convenience given by DBMS for users to utilize the database completely. Any changes, any modification that I do on the conceptual level should not largely affect anyone else in the external level. Likewise, any changes that we do in the internal level should not affect the data structure or database schema. So it is well protected with one another, well protected and well covered between the layers. That is what the DBMS paves way for the data independence in the system. This is the data independence and three levels of architecture. As I said, the external level, conceptual level, and internal level. The logical data independence fixed between the external level and conceptual level, and the physical data independence is been happening between internal schema and conceptual schema. So I again explain in a clear picture. First I explained about logical data independence. As I said, whenever I do any changes in the conceptual schema, like adding a new column or dropping a column or increase the size of the column or change the data type of the particular column, should not affect the external schema, or it should not affect any associated programs for the database. Whenever I do any changes, you should not bring any harm to the external level. You should not largely affect anyone on the users who is utilizing the database. Likewise, if I do any structural changes in the memory, any data structural format being changed in the memory, or any algorithms that I change for processing the internal memory, would not affect the conceptual schema. If I do any changes, memory, blocks, even if I change the database from one place to other place, but still it has to connect to the logical schema. It should not affect the logical schema anyway. That is called a physical data independence. Give an example. Yes, this is the difference between three levels of architecture we have here. The first one is user level. So I have a database that is been defined in the conceptual level. It is staff number, F name, last name, date of birth, salary and branch number that he belongs. Now in this case, this is a complete schema that we define. So some of the data is been shared to external user 1 and some of the data can be shared to external user 2. Likewise, the same database can be given privilege to different users with different data values. If I change anything in the conceptual level, suppose I change the data type of char to varchar for staff number or F name, which should not affect the external level view 1 or external level view 2 because staff number has been referred in both the place. If I drop date of birth from the conceptual level, it should not affect the external level, since in this example there is no date of birth in both the users. So the date of birth can be dropped. Suppose if I drop salary, then it has become a problem because the salary has been referred by the user, external user 1. So we should be very cautious in this aspect. What to do and what not to do. What is the changes we can make over the schema and what are the changes we could not make on the schema. That is called logical data independence. If I do any changes in the logical schema, which should not affect the external level. The user should not be get affected by that. So your changes should be in consideration of the external users. In view of those aspects, we have to do the modification in the table. Likewise, if I do any changes in the internal level, like or I adjust in the memory slots, or I change the data structure for storing the data in the memory slots, or I do the file organization appropriately, or I do the indexing has been changed according to different formats. Either I go for dense index or sparse index, or I do the clustering based on B tree or B plus tree, or I change the database from one location to some other location, or I use the memory which has been referenced by some other organization, some other database. So if I do any sort of changes in the internal memory, we should not affect the conceptual level or even the external level. Obviously, any changes that we do in the external level should not affect the conceptual level. Who is responsible to doing this stuff in the internal level? Only the DDBA, only the database administrator has a full privilege to achieve this task. No other person, the database designer or the sophisticated user or data analyst will have no role here. Only the database administrator will have all the privileges to do this task. Whenever I do any changes in the internal memory, that could not affect the conceptual level. This is called as what? The physical data independence or logical data independence. This sort of independence has been given in DBMS so easily. That is a major advantages. That is why we headed from file system to database management system. That is the reason why we use database for many of the cases. So the data independence says that when a schema at lower level is changed, only the mapping between the schema and the higher level needs to be changed at DBMS, not the other aspects. The higher level schema themselves are unchanged because the program that we write on the for the database should not be changed whenever I change the data structure, whenever I change the file organization, whenever I change the schema of the database. The application program should not change very often. That is not a good practice. It is not an industry ready practice. So your application program should be stay standard and stand alone forever. But the database can change. The internal organization can change. The memory for the database can be changed. But the program remains same. That is the kind of independence that DBMS is providing to its users. I hope you understand this lecture so easily. I believe that you understood what is logical data independence and what is physical data independence. Now I believe that why we studied database in this manner. Happy learning. Thank you.